Hey YouTube, what's up? Dr. T here, and welcome to the Altcoin Express and my hometown of St. Petersburg, Florida.
So, in this section, we will deal with all things pertaining to artificial intelligence, otherwise known as AI.
In this post, we'll go through an article detailing the science behind OPENAI FIVE, the OpenAI bot in a 5x5 team. Delta 2 beat some human opponents. So the science behind OPENAI 5 that just produced one of the greatest breakthroughs in the history of AI. Bill Gates called it a huge milestone in advancing artificial intelligence, and the entire world was amazed last week when bots developed by OpenAI were able to beat humans in a game of Delta 2. The accomplishments represented a major breakthrough in the history of artificial intelligence, comparable to AlphaGo defeating Lisa Doll in 2016. OpenAI's system leveraged state-of-the-art deep learning research to show that AI is actually capable of dealing with messiness and complexity of physical environments in the real world. Delta 2 is effectively one of the most popular esports games in the world, which also produces the largest prize pool in the space, about $40 million. The game is played by teams of 5 people that try to destroy each other using characters such as demons, spiders, and ice ghosts. Conceptually, Delta 2 is a real-world strategy game that mimics the continuous nature and messiness of real-world environments. These changes represent a multiple of complexity higher than previous AI milestones in games like chess or Go. For an AI environment perspective, there are several aspects that make Delta 2 a nightmare for AI agents. Long time horizons. Most actions in Delta 2 have minor impact individually but contribute to the team strategy. The game is about 20,000 moves long compared to an average of 40 moves of a chess match. Partially observed stage. At any given time, a team can only see a small area around them. Delta 2 strategies require making inference based on incomplete data. Continuous action space. Each hero is faced with about 1,000 actions, each tick compared to about 35 in chess. Actions can have completely different objectives, such as targeting an enemy or improving the position on the ground. Continuous observation space. The observation space in Dota 2 includes heterogeneous components such as heroes, trees, whatever that is, buildings, trees, etc. That's a spelling mistake, I think. At any given point, the observations in a Dota 2 game can be qualified as 20,000 floating point numbers. The same qualifications for chess and Go are around 70 and 400 respectively. Reinforcement learning for Dota 2. To address the aforementioned challenges, the OpenAI team developed a system using 5 coordinate neural networks, each representing a different player. Called OPENAI FIVE, the model uses state-of-the-art reinforcement learning techniques such as proximal policy optimization to master the details of the game. Technically, PPO methods are novel policy gradient techniques that allow them to be more efficient and less costly than traditional reinforcement learning methods. PPO proven to be an incredible value method for OpenAI 5 to solve challenges such as exploration. What we got down here. The training. The training of OpenAI 5 bots consists of playing millions of games against different versions of itself. Quantitatively, the experience collected by OpenAI 5 system was estimated something around 180 years per day. To accomplish that, OpenAI team used approximately 128,000 CPU cores on the Google Cloud platform. One of the most remarkable results of the training was the ability for OpenAI agents to maximize long-term rewards over short-term gains. At any given time, OpenAI 5 bots were confronted with environments with dozens of buildings, spells, trees, and diverse number of game mechanics triggered by other players. Exploring these environments, identifying and maximizing long-term rewards over short-term benefits is far from being a trivial task. To train OpenAI 5, the OpenAI team used a general-purpose reinforcement learning system called Rapid implemented on top of the famous gym environment. At a high level, the training system is separated into rollout workers, which run a copy of the game and an agent gathering experience, and optimizer nodes, which perform synchronous gradient descent across a fleet of GPUs. The rollout workers synchronize their experience through readies to optimizers. Optimizers plus connected rollouts, 256 workers. That's quite detailed. I don't know whether it blows up a bit. It blows up a bit, so I'll leave it on the screen for you to take a look at, because I'm not going to go through it and read it all. Okay. The architecture of OpenAI 5 can be seen as 5 independent but coordinated neural networks. Each networks contain a single layer, 1024 unit long short-term memory that uses the current game state and emits actions through several possible action heads. Each head has semantic meaning, for example, the number of tricks to delay this action, which action to select, and X or Y coordinate of this grid in a grid around the unit, etc. Action heads are computed independently. The following diagram explores the architecture of OpenAI 5 networks. So let this stand up there for a while. It'll take a while to glance over it all. And even then, one can only take a transient amount in. So they're using ReLU activation functions maximally. Let's see, yeah, that's the primary activation function they're using. And these softmax, of course, is probabilistic outcomes of events and then actions. Okay, let's carry on. Had a look at that for a bit. Playing as a team, one of the most impressive achievements of OpenAI 5 was the ability of independent neural networks to coordinate actions as a team. Even more surprising is how simple but clever is the current implementation of the coordination model. OpenAI 5 team efforts are controlled by teamwork, is controlled by a hyperparameter called team spirit. Team spirit ranges from 0 to 1, putting a weight on how much each of OpenAI 5's heroes should care about its individual reward function versus the average of the team's reward functions. We annealed its value for 0 to 1 over training. The reward system in OpenAI 5 consists of a combination of aggregated metrics such as net worth, kills, deaths, assists, or last hits. The reward algorithm post-processes each agent's reward by subtracting the other team's average reward to prevent the agents from finding positive sum situations. At the beginning of the training, the OpenAI 5 agents were only able to walk around the environment, but after a few hours they developed concepts such as landing, farming, or fighting over mid. After several days, they consistently adopt basic human strategies, attempt to steal bounty runes from their opponents, walk to their tier 1 towers to farm, and rotate heroes around the map to gain lane advantage. A major milestone. OpenAI 5 represents a major milestone in the ability of AI systems to operate in real-world environments. The current version still needs some work to play at professional level with Dota 2 teams, but you can fully expect it will be there in a few months. If you have any doubts, I will leave you with the impression OpenAI 5 playing Dota 2, so we can look at this again because it's so much fun.
It's like playing against a smarter version of me. Good luck, Dendy.
You think he's got a shot?
No.
Okay, I give up.
You giving up?
Yeah.
To train our bots, we use reinforcement learning with self-play. We run the game on over 100,000 CPUs, and our bots learn from every game they play.
It's played so many games of Dota, it's played for really lifetimes of experience.
In the bottom left is a graph of the bot's value function, which is the reward the bots predict they will receive in the near future. Crystal Maiden ganks the human sniper and begins channeling her ultimate, and as time goes on, the bot team becomes more confident that it will win the skirmish. After taking out Sniper and Lich, they roam bottom, clearly still expecting to receive a high reward. They bait the human Viper into engaging on a lower level Lich, and then collapse on him to pick up an easy kill. In this scene, the bots ambush the human team, and the human Crystal Maiden runs into the trees, hoping to escape. The bots follow her, trying to regain vision so they can finish her off, eventually finding her. Here, the human sniper attempts to kill the bot Necrophos in mid lane, and as the Necrophos is taking damage, he pulls back toward his tower, forcing the sniper to overextend. The Necrophos teammates surprise the sniper from behind and manage to take him out. The bots manage to find Sniper alone and use practically every high cooldown they have on the single hero. And this one kill ended up winning them the game. In this scene, the human sniper lost, but managed to survive a 1v1 skirmish against the bot Lich. Lich chases the sniper, often losing vision on him, but still correctly guessing which direction he's gone. Eventually, he's able to catch up and finish him off. Here, the bots are trying to make a move on the human base, and they're one barracks away from mega creeps, but are unable to take the barracks while the human team is defending. The bot Lich ends up getting fairly low, and as the humans go to finish him off, instead of running towards his team for safety, he runs in a different direction, tempting them to chase him, and in doing so, abandon their base. This allows his teammates to take the last barracks.
Well, you heard this
So
just
sick.
the beginning, right? Technology's changing our